Okay, in my last video I was working problems involving the law of signs, the ambiguous case. I had worked two examples. I had done A and B. The instructions are given, two sides and an angle are given. Determine whether the information results in one triangle, two triangles, or no triangle. Solve any triangle that it results. Okay, in the last video we found that in part A there was no triangle possible. In part B there was one triangle possible. And now I'm going to work a problem, which in this case is C, where there are two triangles possible using the law of signs. Again, these are referred to as the ambiguous case. So in part C, you're given B, side B is 8 units, side C is 9, and angle B is 18 degrees. So we set up our formula with the information given. So I'm given angle B and side B, and I'm given side C. So it makes sense then to say that the sine of angle C divided by 9 should equal to the sine of 18 degrees. Divided by 8. Okay, so here you want to solve for angle C. Get my calculator then, and we're just going to divide this out then. So turn the calculator on, and mine is set to degrees. We're working with degrees, so make sure you know what your calculator is set to. So I'm just going to do the right side first, and I'm going to say it's the sine of 18 divided by 8. And then I'm solving for sine of C, so multiply both sides by 9, so this will be times 9. Okay, so this tells me that the sine of C is 0.34 or 0.35, say, to two places. So I do have a solution. Remember, in the case where you have no triangle possible, when you get to this particular point, if you have no triangle possible, this value right here will be larger than 1 or less than -1. So the only way you're going to have at least one solution is if this value right here, after you solve for the sine of the angle, has to be a number between -1 and 1. So in this case, then I proceed then to find the sine inverse of this. So I hit second, sine inverse, and I want it out of that answer. So hit that, hit enter, and I get 20.34 to two places. So in this case then I would simply write out angle C to two places is 20.34. degrees. Okay, so if we have two triangles possible, for the first solution, angle C will be 20.34. And as I mentioned in the previous video, the supplement could be a solution also, and in this case it is. So subtract 20.34 from 180. And we get 159.66. So I'm just going to write S for supplement. So the supplement is equal to 159.66. There it is. And remember, the way you know that you have two solutions is you take the supplement, which is right here, and add it to the given angle, which is 18. Okay, so 159.66 at 18. If that value is less than 180, then you have two triangles possible. If that value, when you add it up, is greater than 180 or equal to 180, then you have one triangle possible. Okay, so in this case, you can see that if you take 159.66, add the 18 degrees, you will get a value a little less than 180. So there are two triangles possible. Okay, so this is what we're going to do for the solution one. So solution one, $20.34 would be a value for C, and also 159.66 would be a value for angle C, which is the supplement. So over here, then I'm going to say, since there's going to be two values for C, I'm going to call the first one C1. So this will be C1 then will equal to 20.34 degrees. So this is for the first triangle that I'm doing. Okay, so 20.34. Okay, now and this is capital C here. Okay, it's an angle. So now I want angle A. And again, there's going to be two values for angle A. So I'm going to call this one A1. Okay, so what you would do here then to get angle A1, we know two of the angles. Okay, so the given angle is 18 degrees. And we found C1 to be 20.34. So add up the 18 degrees and the 20.34 and subtract it from 180. And we're going to get 141.66 degrees. We need side A1. Again, there's going to be two values for A1 because, again, the length of A1 is going to depend on the angle opposite. So angle A1 is going to change. So I'm going to do it this way. A1, using the law of sines here, A1 divided by the sine of the angle opposite A1, which is angle capital A1. So this will be 141.66 degrees. Okay, that should equal to any other side, and of course we'll use the given information, so that would be 8 divided by the angle opposite that, which is 18 degrees, so this would be sine So now you use your calculator. So just to save us some time here, you would take 8 divided by the sine of 18 degrees. Make sure your calculator's in degree mode. 8 divided by the sine of 18 degrees. And then times, multiply that by the sine of 141.66. And you'll get that A1 is equal to 16.06. There you have it. So for the first triangle, the solution is obviously you're still using the given information. So side B is 18, side C is 9, side B rather is 8, and side C is 9, and angle B is 18 degrees. And then the rest of the information is here. Angle capital C1 is 20.34. Angle capital A1 is 141.66. And side A1 is equal to 16.06. Now for solution 2, for the second triangle, we're basically going to repeat this procedure, except we're going to use for C1, which we're going to call C2 because it's for the second solution, it's going to have this value of 159.66. But it's going to be pretty much the same. So let me just clear this. And here's the way it's going to work then. For the second solution, okay, so this is solution 2. It's for the second triangle. C2 will be 159.66 degrees. Okay. This information here is still the same. This is still given. B equals to 8, C equals to 9, and angle B is equal to 18 degrees. Okay. So now, obviously, because the value of angle C changes, the angle of A is also going to change. So again, let me erase this. So angle A, and I'm going to call it A2, since it's for the second triangle, is going to equal 2. So again, now you have now the two angles are 159.66 and 18 degrees. So add up 159.66, add 18 to that, and subtract that value from 180, and angle capital A sub 2 is going to be 2.34 degrees. Okay, so for the second triangle then, we have angle C2 is 159.66, and angle A2 is 2.34, and of course the given angle B is still 18 degrees. So now we need side A. But again, it's going to change because the angle opposite changed, so we're going to label it A2. So again, using the law of sines, A2 divided by the sine of the angle opposite, which is, of course is 2.34 degrees, is equal to, say, another side given, 8 is given, so we use that, divided by the sine of the opposite angle, which is 18 degrees. Okay. This is 18 degrees. Okay, so use your calculator 18, or take 8 I should say, and I erased what I didn't want to erase, so let me put it back. So here's what we had. We had A2 divided by the sine of 2.34 degrees is equal to 8 divided by the sine of 18 degrees. Okay, that's what I cleared. That was the last step I had. So you take 8 divided by the sine of 18 degrees, multiplied by the sine of 2.34 degrees, and you'll find that A2 is going to equal to 1.06. So A2 is equal to 1.06. Okay, so for the second triangle, again, even though I cleared it over here, for the second triangle, then we find that angle C sub 2 is 159.66. Angle A sub 2 is 2.34 degrees, and side A, little a sub 2, is equal to 1.06. Okay, so this is what you have to do then when you have two triangles possible. Okay, so these again are examples where you're given two sides and the angle opposite one of the sides. And this is the ambiguous case again, and it can lead to no triangle, one triangle, or two triangles. In this video here, we looked at the case where you can have two triangles. Okay, in the next video, I will continue with the law of cosines. And then after that, another video dealing with applications of these types of problems. So please subscribe to the channel, and we'll see you in the next video.